In this topic, we understand the concept of default correlation in credit portfolios. Default correlation measures how likely it is that multiple firms will default together, instead of defaulting independently. This is very important in credit risk because joint defaults can lead to large portfolio losses. Let us consider two firms. The probability that firm 1 defaults is pi1, and the probability that firm 2 defaults is pi2. There is also a joint probability, denoted by pi12, which represents the probability that both firms default together. We define two variables, x1 and x2. Each variable takes the value 1 if the firm defaults and 0 if it does not. Based on this, there are four possible outcomes. The first case is when only firm 1 defaults, with probability pi1 minus pi12. The second case is when only firm 2 defaults, with probability pi2 minus pi12. The third case is when both firms default, with probability pi12. Finally, the fourth case is when neither firm defaults, with probability 1 minus pi2 plus pi12. Now, let us look at expectations and variability. The expected value of each variable is simply the probability of default. So, x1 equals pi1 and x2 equals pi2. The expected value of both firms defaulting together is x1 x2, which equals pi12. The variance of each default indicator follows the Bernoulli formula. So, var xi equals pi multiplied by 1 minus pi. This applies for both firms. Next, we calculate covariance, which measures how the defaults move together. Covariance is given by x1 x2 minus x1 multiplied by x2. This simplifies to pi12 minus pi1 multiplied by pi2. Finally, default correlation is calculated by dividing covariance by the product of standard deviations. So, the formula becomes rho 12 equals pi12 minus pi1 pi2, divided by the square root of pi1 into 1 minus pi1, multiplied by the square root of pi2 into 1 minus pi2. If pi12 equals pi1 multiplied by pi2, the defaults are independent and correlation is 0. If pi12 is greater, the defaults are positively correlated. If it is smaller, the defaults are negatively correlated. So, default correlation helps us understand how credit risks are linked across firms, which is crucial for managing portfolio risk. Drawbacks of correlation-based credit portfolio framework. First, a major drawback is the large number of required calculations. As the number of firms increases, the number of possible default outcomes grows exponentially. For n firms, there are 2n possible outcomes, but only n plus 1, plus n minus 1, 2 conditions to estimate. For example, with 10 firms, there are 1024 possible outcomes but only 56 conditions. This makes the model complex and difficult to implement in practice. Second, the model often simplifies pairwise correlations by assigning a single non-negative value. This assumption may not accurately capture the true relationship between firms, especially when correlations vary across industries or economic conditions. Third, some credit instruments do not fit well into this framework. Instruments like guarantees, revolving credit facilities, and other contingent liabilities behave more like options and cannot be properly captured using simple default correlation. Similarly, credit default swap (CDS) basis trades may involve technical and liquidity factors rather than just credit or market risk. Convertible bonds also combine features of both debt and equity, making them harder to model. Finally, there is a limitation due to lack of sufficient data. Defaults are rare events, so estimating correlations is difficult and unreliable. As a result, correlation estimates vary significantly depending on the dataset, time period, and industry. In practice, correlations are often assumed to be low, typically around 0.05, which implies that joint default probabilities are even smaller. Overall, while the correlation-based framework provides a structured approach, its practical limitations reduce its effectiveness in real-world credit risk modeling.